Right, today we're going to be using a formal written method to calculate multiplication. To be successful, you're going to be using your place value knowledge and times table knowledge in order to calculate. You're going to identify the calculation within a problem, and by the end you'll be able to apply that written method to solve a decimal multiplication calculation. First of all, you'll notice task 1 is some problems. This is just to refresh our memory of how to do our column method for multiplication. So Lauren made cookies for a bake sale. She made 345 cookies. The recipe stated that she should have 12 chocolate chips in each cookie. I want to know how many cookies she needs altogether. So first thing I'm going to do is highlight my key information. I'm not fussed by her name or what she's making necessarily, but I do need to know she's made 345. And I do need to know that the recipe says that there should have 12 chocolate chips in each one. I want to know how many chocolate chips there are. So let's draw a cookie. And I like nice big chocolate chips. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's my 12 chocolate chips in my cookie. If she made one cookie, then I would only have one lot of 12 chocolate chips, so it would be 12. If she made 2 cookies, then I would times 12 by 2 to see how many. There's another cookie. Oh, didn't want white. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then I would do 12 times 2 because there are 2 cookies and I have 24 chocolate chips. If I wanted 3 cookies, she baked 3 cookies, then I would have another lot of 12, and that would be 3 lots of 12, 36. So my question is asking me that she's made 345 cookies, so 345 multiplied by 12. That's the calculation I need to do. Now first thing, before I go into my written method, I need to estimate to see if at the end I'm in the right sort of ballpark, if I'm going to be correct or not. So the best way to estimate is either going to round 345 to a nice easy number and multiply it by 12, or I'm going to round 12 to a nice easy number, multiply it by 345. Now I know the nice easy number that I can round 12 to is going to be 10. That makes it a very easy calculation for me. I'm just making 345 10 times bigger. And I need to remember that because I've made 12 smaller by 2 lots, then my answer is going to be bigger than what my estimation is. I need to keep that in mind after this part. So let me just re-highlight. I've done 345 cookies and I'm multiplying it by 12, and I want to know how many chocolate chips there will be. So first thing I'm going to ask myself here is, have I set out my column method correctly? Have I lined up my ones? Yep. My tens? Yep. And hundreds? Yep. I've got 3 and obviously no hundreds underneath. I've already drawn my lines, but you may just want to do one at a time, and I've put my multiplication sign to always remind me that I am multiplying, so that I don't for some reason decide to add or subtract. So first thing I'm going to ask myself is, I'm going to start with this 2 here, and I'm going to multiply 2 by all of the numbers on top. So what is 2 times 5? That will be 10, so my 0 goes in there, and I carry my 1 across to the next column, and I'm going to carry it on top of the line, or on the line, so that later on when I come to add them all up, I'm not going to accidentally add up that 1. 2 times 4 now is 8, add that 1 is 9, I've got nothing to carry, and 2 times 3 is 6, there we go. Next thing I'm going to do is I'm going to multiply that 1 by everything on top. But that 1 isn't a 1, it's a 10, because there's one 10 in 12. So I can either do 10 times 5 or 10 times 4 and 10 times 3, but to make it easy for myself, I'm going to remember that if I put a placeholder in there, I am making it 10 times bigger. So I can just think of it now as 1 times 5, just 5. 1 times 4 is 4, 1 times 3 is 3. No carrying needed. If I did have to carry anything on the bottom, then I would put it on this bottom line here, so that I don't have to add it up accidentally afterwards. Now last step I need to do is I do now need to add up those 2 parts. So 0 add 0 is 0, add 9, add 5 is 14, carry the 1, 6 add 4 is 10, add the 1 is 11, 1 add 3 is 4. So how many chocolate chip cookies does she have altogether? She has 1,440 chocolate chip are needed. What I'd like you to do now is I'd like you to apply that level of thinking and that knowledge to solve these 4 questions. These will refresh your memory of how to use column methods. They start on 3 digits by 2 digits and they go on to 4 digits by 2 digits. That's where you ended up in the autumn term, so that's where we're starting now. When you're ready for task 2, then play the video again and come back for that. Right, okay, task 2. How will I answer this? Use a greater than or less than sign or an equal sign to make this statement correct. I've got 3,421 multiplied by 15, a giant circle where I'm going to put my sign, and then 847 multiplied by 58. Now the best way I can do this is to find out what those values are. So what does this side equal? What does this side equal? And then I can see which one's bigger or if they are the same. So I'm going to set up my column method there. First thing I need to do is I'm going to start with my 5 and I'm going to multiply 5 by everything on the top. So 5 times 1 is 5, 5 times 2 is 10, I'm going to carry that 1 on top. 5 times 4 is 20, add that 1 is 21, I'm going to carry the 2 on top. 5 times 3 is 15, add that 2, 17, and because I know that I've got nothing else to do, I'm not going to carry it on top, I'm just going to put it next to it. Next part is I'm going to do my 10 times everything on the top. So if I use my place value holder, that makes it 10 times bigger. I can go 1 times 1 is 1, 1 times 2 is 2, 1 times 4 is 4, 1 times 3 is 3. Now I'm adding them up, so 5, 1, 3, 11, 5. So I've got 51,315 on that side. This side over here, I'm going to write out my calculation, making sure I line up the columns correctly. So here we go. 8 times 7 is 56. I apologise. So 56. 8 times 4 is 32. Add the 5 is 37. 8 times 8 is 64. Add the 3. 67. 5. Now I'm going to do 50 times everything on the top. So remember my place value holder, then I can do 5 times 7 is 35. And this time I do get to carry it on the bottom. And you see how I've done it along that bottom line. 5 times 4 is 20, add the 3 is 23, carrying on the bottom line again, and 5 times 8 is 40, add that 2 is 42. I'm going to add them up now, so I've got 6, 13, 11, 9 and 4. So we've got 49,136. So which one is bigger? My 50, I'm not happy with that. There we go. My 51,000 is bigger there. What I'd like you to do is, now I'd like you to tackle task 2, telling me which one's bigger, which one is smaller, exactly how I've done that. When you're ready for task 3, come back and I will do task 3. Okay, task 3, how would you answer this? Here I have a written calculation for multiplication and I have some missing digits, missing values. So my job is to fill in those missing values. I've got 3 digits that are missing. Now I noticed that I can solve one of these digits without any multiplication knowledge at all. Because if I were to cover up that multiplication part, then all I have there is a simple addition calculation. 4 add 0 is 4, 4 add 8 is 12, so then I would be realising that I've got 1 to carry there. So 7 plus something equals, well, plus 1 must equal 2. Well, that doesn't make sense. So this must be 7 add something add 1 equals something ending in 2. Now I know what ends in 2? Well, 2, but we said that can't work. 12, 22. I don't think I need to go any higher than that because I'm pretty sure it's going to be 12 there. So 7 add something, 7 add 1 is 8. What do I need to add to get to 12? Well, that would be 4. And let's just double check. Let's see, it is 12. 2 add 1 there makes my 3. Great. Okay, so I have that one done already. That was just a nice easy addition to find that one. Here's where it gets slightly trickier. My 2 at the top. First of all, 6 times this, missing 1, must equal something ending in 4. Because I know it can't equal 4 because that 4 isn't in the 6 times table. So it must equal something ending in 4. So I'm going to see what ends in 4 in the 6 times table. Well, 24 does, which is 4 times 6, and 54 does, which is 9 times 6. So let's see. 9, will it be a 9? Well, if that was a 9, then I would have 54, I'd be carrying that 4. 6 times 2 is 12, add 5 would make that a 7, because there would be 17. Oh, well it's not a 7. So it can't be 9. So it can't be that one. So it must be my 4 here. Let's double check. 6 times 4 is 24. 6 times 2 is 12. Add that 2 would be 14. Yep. And then 6 times 1 is 6. Add the 1, 7. Brilliant. So that must be now correct. Let's use that same knowledge, same thinking, to find my last missing value here. So something times 4 must equal 80 or 8. Let's think of this as well. Place value holders there, so I can think of my missing value as a singular digit. So it'd be something times 4 equals something ending in 8. So it could be 8 there. It could be 2 times 4, or it could be 28, which is 7 times 4, or it could be 12 times 8. Well, I know it's not going to be 12 because I only have a 1 digit, so that one can't work. Let's see if it's the 7 times 4, which is 28. So let's make that 7 now. So it'll be 7 times 4 is 28, so I would carry the 2 to get 28. 7 times 2 is 14. Add that 2 would make 16. Well that's not what I had before. So it can't be the 7 in there. So hopefully it's the 2 then. Because 2 times 4 is 8. Yep, that would work. 2 times 2 is 4. That would work. And 2 times 1 is 2. That would work. Great. So I've now solved them all. I've missed a 4 on my 4th row, a 2 on my 2nd row, and a 4 at the top. So you see how I've used my times table knowledge and I've sort of thought backwards on how to solve these. So what I'd like you to do now is have a go using that same strategy for task 3. You've got 3 questions to solve there. When you're ready for task 4, then come back. Okay, final part to this lesson then, task 4. How would you answer this? I've got 27.5 times 26. My problem here is this decimal place. That's what's making it difficult for me. So what I'm going to do here is if I multiply that by 10, then that gets rid of my decimal place. I'm not going to do it to the other side just at the moment. I'm going to do a little cheat here. If I multiply that by 10, then my calculation I could be doing is now suddenly a lot easier. Now I need to remember I've done that at the end. So now I'm just going to calculate it without the decimal point. Almost like forgetting about it for the moment. There we go. Calculate it without it. Forget about it. 6 times 5 is 30. 6 times 7 is 42. Add the 3 is 45. 6 times 2 is 12. Add the 4 is 16. Remember my placeholder. 2 times 5 is 10. Carry the 1. 2 times 7 is 14. Add the 1 is 15. 2 times 2 is 4. Add the 1 is 5. Now I just need to add them up. There we go, right. So the answer to 275 times 26 is 7,150. Now all I need to remember to do is this part. I put in a decimal place. Or effectively actually I took it away. So I need to now put it back in there. Now I need to ask myself, I have now made it 10 times smaller. Or, in another way, is I have one decimal place there. I've got one digit after a decimal point. So in my answer, I'm going to have one digit after my decimal point. 27.5 times 26 must equal 715 exactly. Now let's say, for instance, I'm going to change colour here, that I had another decimal place here. There was 27.5 times 2.6. Once I've taken them both out and done my calculation, I would then have to put them both back in. So I would have one up here like normal, so I'd have one decimal place there, and I'd have one here, which is a second decimal place. So that would effectively be the same as making it 100 times smaller. So I'm going to have a second decimal place down here, and my decimal point is going to go in front of it. So if I was to have 27.5 times 2.6, my answer would be 71.5. What I'd like to do now is apply that thinking to these questions down here. And so the first three only require one decimal place, so what I was doing in pink before. They're fairly simple, just adding it back in. The extension then goes on to 2 and 3 decimal places after the decimal point, and you have to apply that knowledge I was talking about when I was writing in blue just then. I'm sure you've all seen before. Any other problems, all answers are at the bottom.